So, one of the original goals of RS PAC was kind of just to be this drop-in replacement for Webpack and to like completely support the API. Uh, that works in the beginning, but as you said, new things are going to be unlocked. So, like, what has RS PAC like worked towards that's kind of like innovations on top of Webpack rather than just like matching the old API?
Okay, so I guess to go back a little bit as well for some context on why we went this route. So we didn't just like go, let's port Webpack, and that was the plan. That was the last thing that we did. So we have like pages and pages of documents. I think there was something crazy. I think like people who people from ByteDance have worked on every Rust bundler except TurboPack, as far as I'm aware. So most of them that are on the market, like in some way, shape, or form, some origin story can be traced back to that person's time working here. So there's just a ton of knowledge in building these Rust bundlers, and like 60% of them came from people who had started working on those here, maybe left and took it further, whatever. But like there was a lot of like catalysms here around bundler research and doing this. So the big thing that we have discovered is writing a bundler is actually not as hard as it sounds. The real problem is the API design and how that ends up biting you down the road. So when we started, we actually were like, okay, well, the first version of RS Pack actually was ES build, and we rewrote ES build. And so for a time, we were thinking of calling it Go Pack, and it was going to be written in Go. The problem with Go that we found is it doesn't do well with bindings to JS with like very complicated bindings. Mostly like you have a garbage collected language to a garbage collected language, and that doesn't play so nicely. So then we kind of looked, okay, let's look into the Rust side of it, moving ES build into Rust, and let's just fix some of the problems ES build has, because it was almost, good enough for what we needed. At the time we were just building our links apps with it. So we needed it was originally called Speedy. So we needed a speedy solution for links. And that was, hey, ES build can almost do the job there, but if we could just fix these issues, perfect. What we ended up finding though is like there were bigger challenges in like ES build, for example, like if trying to fix the code splitting so that it chunks the code better, or HMR. There's like architectural challenges that make that not just easy to add. Like the dev just doesn't want it in there, but it seems to be like, well, there's fundamentally it's a little bit trickier to try and do that. Um, so we kind of ran into this wall a couple times where it's like, oh, well, let's try and create something new. And then it's like, okay, well, then there's the explosion of what ifs that come in that haven't necessarily been thought through, and it's uncharted territory and so on. So we had two main issues. One, we had a lot of things using Webpack. We were also investigating Vite at the time because Vite was getting popular. We were like, hey, maybe we could switch over to that. And maybe that could work. And so then one of our infra teams ended up building, I don't know if you guys know Farm.fe. Have you heard of that bundler?
I think I might have been on the page before.
Yeah,
That sounds familiar.
Farm.fe. So anyway, so Farm actually started out as Ploy. So our infra team was split into two sections. One half of the infra team was building RS Pack. The other half of the infra team was building Ploy. We reorged, folded the compiler teams together to reduce redundancy, and then I think the main guy behind Ploy left the company and released Farm, which was like which is essentially like from all the work that they had done in Deploy, packaged it up and put it out there. And from what I understand of Ploy was the idea was to have like almost a Vite type compatible API, just very quick, and solve the problems that we were impacted by, that there was no world out at this point. So this was the way that, they were going out to solve it. So we wrote like, I think maybe 5 bundlers in total, like getting through to this point. The reason we ended up on Webpack is, again, design issues. Oh, well, we can extend it here and there, but then like there's all the unknowns and race conditions coming in, which essentially just makes the risk too high to look at. So what we thought is, okay, well, probably the easiest solution would actually be to take something tried and tested that we know is guaranteed to work for all the business cases, and that was Webpack, which is a lot more complicated. But the nice thing with Webpack is it's also got over 10 years of testing behind it. And so it's pretty solid to start with that. So if we could port Webpack into Rust and say we have a foundation that we know has 10 years of like, here's all the things that all works, it's all very well tested, then we could start to enhance and iterate on it, knowing that we actually have a stable replica of a powerful bundler to begin with, which is a lot less complicated than trying to design one that could be that or more in the future. So 2024 was largely get parity, get stability with the APIs. Like a lot of it was speed doesn't matter. It's about artifact quality and making sure we have like a one-to-one, or, make sure it works safely. Like make it safe and then make it fast, essentially. So in 2025, now we're looking at speed opportunities. So I would say like things that we've been considering as like, time is going to evolve on. So there's a bunch of like various things, but we're quite interested in a lot of what the TurboPack team has been cooking up, and so we've had a lot of those plans in our plans since like mid 2024. So things like remote caching, function level caching, cache that you can share between different developers. That's something we're very interested in. I think we already have like function level code splitting as well, so you can move single functions out of chunks. Which these aren't, super, like most people don't really care about those type of like minutia, but basically it means you can make like a lot more fine-grained implementation, and a lot better code splitting, tree shaking, stuff like that. Another big area though that we want to look into, I think we've already started the work, but is going to be into a what is it? Into a unified build graph. So essentially saying, I want to build to an edge worker, a native device, a node server, and the browser, and I want to do it all from a single build, and then I want certain imports in that build to remain under certain boundaries. So like building the whole module graph that could control potentially 3 to 4 layers of your deploy stack, but it's understood as a single system to the runtime. So this is something TurboPack has also been working on. So what I would say probably is a lot of the future things that we would consider is going to be, we started with aligning to Webpack, we have a stable core, then now looking at things like what Turbo is doing, how can those be incorporated? Because we think a lot of those problems, again, are things that kind of align with the problems that we would like to see solved. Some other areas, though, like, a kind of an interesting one is, like, there's still a lot of room in tree shaking and dead code elimination. Like, my personal opinion has always been whoever builds a compiler that produces the smallest bundle would most likely win, like, the bundler war. Because regardless of how developers feel about it, or if they say, oh, well, they love this ecosystem so much, that doesn't matter if you can produce 50% less payload to the end user. Like the user wins, and if you can serve them twice the lighthouse score, like the business will override any engineering just because of like depending on the industry. But that's what I would say. If you can produce a smaller artifact, all the other points are moot. Like everybody's going to go for smallest thing to ship to user, best experience. At least that's how I kind of think about it. But tree shaking and dead code elimination is really tricky. However, most modern bundlers still leave about 40 to 50% dead code even after optimizing. So that's how much still could be done. And so one thing we've been looking at as well, we've been working, I think, with KDY on some of this too, but looking at how could we use dead code elimination and tree shaking by using the TypeScript syntax to help inform the bundler of what's going on. So usually when you build things, how it works is you take your TypeScript code, convert it into JavaScript, pass it to the parser reads it and does whatever. So you lose a whole bunch of things like, oh, well, if they were private, if this class is private, you could check, well, is that method actually used in the implementation? If not, we know that outside you can't use it because it's marked as private. So it's safe to tree shake if we don't find any inner graph linkages. So I think there's a ton of information like that we could extract, which would really help with like how a bundler can understand the app using like a better syntax or, a more informative syntax. Some other things that I know we've been playing around with was we had the idea of being able to use hot reloading to redeploy production. So HMR was designed for production use, and nobody really did that. So something that we've been looking into, well, is imagine if you need to perform like certain hot fixes. Instead of having to redeploy the entire code base, what if you could just push the hot update chunk into an existing app? So if you just needed to add the patch and the patch was only 1 kilobyte, you're essentially just pushing an extra KB into the existing app, and all your users could get it, and you could hot reload them, not preserve state in the browser, but you could effectively do things like that where your deployments just become hot reloads um, to the pipeline. So, those are probably some of the more interesting areas. Then I know we're also getting into like stuff with AI and other things like that. So what I kind of see is potentially somewhere down the line where these things kind of like mash into something like combined, where you essentially have like a environment that's then custom built, and then potentially we could bolt on some kind of like agentic system to it, and we have a dot site system that's designed to be parsed by like a indexer for like a question and answer bot, and you would be able to have a code sandbox because we have like yeah, like essentially, we have enough of the loose parts where we could probably do more interesting things like that. I'm personally quite interested to see. I know we started on it, but like MCP, for example, hooking up our build doctor, RS doctor to MCP servers, and now your AI would be able to understand what's going on in the build. And what if that could go a bit further and you had like some knowledge graphs? So like the compiler helps serve, here's the application, here's how it's working, and potentially kind of, starting to utilize the bundler almost like as a language server of sorts. To find context and understand relationships about like manually splitting chunks and doing things like that. I think a lot of problems that you have in like AI and in like RAG is very much the same thing as bundler. It's just you're serving a different type of module back, which is like a text chunk versus a script chunk. Um, but yeah, so there's some kind of interesting things that I could see floating around here. But I think in general, a lot of it's going to be on how do we make it, faster. Like I think mainly the big things right now are speed, improving the unified graph structure, because that would open up doors like RSD and other areas like that. And so something we've also been kind of considering is, what if like something like RSD wasn't bound to React? But what if there was like a bundler level protocol of some kind that fits within, that kind of paradigm? Because if you have like a unified graph and you can build the server, build the edge, build the browser, and the build is aware of where every part is going to be going, but also the runtime is aware of it as well. So the runtime could know that, hey, this is a server module per se. But what if you could kind of bake that into, well, this is just how like importing certain code works, rather than like, oh, well, here's React server components and you have to pass it props. But theoretically, you could do the same thing where you say, hey, here's bindings to a function that you get on your end, and there's bindings that are going to translate into a network related call or call to a worker, and then get decoded on the other end. Kind of using a similar kind of principle as like what RSC would do. And I think that particularly for something like links, that would probably be very useful, because we already have this use main thread, and like using the background thread, you do parallel like multi-threaded processing on there. And so being able to do that more sophisticated without needing to kind of glue certain parts together, I think, would be quite interesting. I think this is where it would be nice to say, oh, well, Links already uses this thing where it's kind of like RSC, but it's built into like Links itself. Now, what if like the bundler itself had like a universal way to handle this problem of like, here, communicate with resources that might not be here, but to you, they feel like they are.